session for today. I will be covering something called uh, cost estimation and quantity takeoff for civil works, and specifically, of course, for roadworks. But the knowledge that you get here will be mostly help you in the kind of projects that you work on. I understand that most of us have not managed to proceed with the project. So what we're going to do, because I'm not seeing anyone saying what is the challenge, possibly it's because we are a little bit busy, or possibly because we are deciding maybe to work on it at a later time, and that is also okay and allowed. So let us proceed so that also we don't waste your time. I would like to hear what is your understanding on cost estimation. That is after watching this short video that I had selected here for you. And then from that, we can be able to go to the fundamentals, or rather to the real thing that we need to cover. So let me share my screen. You may confirm uh, whether you're able to see my screen and hear the audio clearly. So I'm sharing.
How to do cost estimation. If you are curious about how to accurately estimate costs for civil engineering projects, you are in the right place. Cost estimation is a key part of civil engineering project management. It helps ensure that projects are completed on time and within budget. Let's break down the process step by step. First, you need to identify the estimating method that suits your project. There are several methods available, each with its own pros and cons. One common approach is unit cost estimating. This method calculates the cost of individual units of work, like the cost per cubic meter of concrete. Another method is assembly estimating, which breaks the project into major components, such as foundations or electrical systems, and estimates costs for each part. You might also consider parametric estimating. This approach uses statistical models and historical data to predict costs based on project variables like size and complexity. Lastly, detailed estimating is the most accurate method. It involves listing every item and task required for the project and calculating their costs individually. Next, gather all relevant project data. This includes design specifications, materials needed, and labor requirements. Having detailed information is essential for making accurate cost estimates. Once you have your data, it is time to calculate costs using your chosen method. For instance, if you are using parametric estimating, you would apply mathematical equations based on historical data to predict costs. Do not forget to consider contingencies. It is wise to include a contingency fund in your estimate to cover unexpected expenses or changes in project scope. This helps to avoid budget overruns later on. After preparing your initial estimate, review it for accuracy. This may involve revising assumptions or incorporating feedback from stakeholders. It is important to refine your estimate to ensure it reflects the most accurate costs. Finally, present the finalized cost estimate to stakeholders. Make sure it is clear and well documented. In civil engineering, cost estimation is not just about crunching numbers. It plays a vital role in ensuring that the project is feasible and can be completed within budget. Effective cost estimation contributes to planning, resource allocation, and risk management. By mastering this skill, you can set yourself up for success in your civil engineering career. Whether you are just starting your education or looking to advance in your career, understanding cost estimation is essential for any civil engineer.
Thank you very much. We can make it brief. Uh, what exactly are you getting about the importance of cost estimation? And if you've earned this experience again, you can be able to share briefly for just like 4 people. And then from there, we can be able to proceed. So please, the mic is open. you may pick it up and speak with us. Anyone? Anyone, please? What is your understanding of cost estimation or quantity takeoff uh, for civil engineering works for roadworks?
Hi, good evening.
Good evening, Rashid.
It's a very critical thing for every product because there is cost involved. If you make quantities wrong, it will be maybe a big disaster for your whole company. So this is very, very critical point for every company. So for the road work, we are calculating road base and aggregate and all that things. And we need exactly accurate quantity and depend on the which phase you are doing the quantity. At the start of the project, they need some lump sum quantity. Mean there can be a little bit variable in a quantity, so acceptable in the start. So because they are going to get as soon as possible the approval of the supplier. So the important thing in the start of the project, who is supplying the material. So there are many documentation required in the start, and many certifications, many approvals. Then also the quantity also mean estimated quantities is required at the start of the project. But in the later stages, they need to be accurate quantity. So the company will not lose much money to take any wrong material or any extra material which is useless later on. So I think they are hiring very good people for the quantity. And this is my insight only, which I want to say. So this is a backbone for the finances of the company. So
Thank you.
that's all. Thank you.
All right. Thank you, Ali. I think that's a very comprehensive. So you just talked about the stages and, of course, the importance and the stages of cost estimation that we mostly have in civil engineering project, and, of course, their impact altogether to the project. So when we're talking about cost estimation, I would like to hear from one more person as we proceed, please. Thank you. Somebody else? And maybe you can tell us how you have done them before or how you've had, that's how it's done, so that then we can create a common ground to start for this session.
Sorry to join again to you. So in the start, we are making quantity by making some sections on different interval of the road. So we are
Mm-hmm.
checking cut and fill, how much cut and how much fill with the help of natural ground levels and our design profile, what we are prepared. So we are checking with the difference of that two things. And we are taking sections every 10 meter or 5 meter. It's agree with the consultant, what consultant want, how consultant want. Then we make that sections, then we making average quantity of that area. We are considering, okay, from this chainage to this chain, like 5 to 10 chainage is the difference is this much. Then the quantity surveyor are very sufficient on a big project, so they are calculating like this, and it was very lengthy project. And there is, and also people was using the lists on in old time, but because of civil 3D, it's very easy to calculate the things, but the accuracy is more important. You can calculate any wrong quantity without any more thinking. You can create surface and just take the quantity, but the accuracy of the surface and the requirement of your quantity is more important. If you are applying your correct data and your correct method on the both services, then the quantity will come perfectly. Otherwise, there will be a problem. Also, Civil 3D calculating higher quantity because you are not giving proper feedback. You are not providing proper input to Civil 3D to get exact quantity what you need. So this is the other thing we can say something about. I mean, what is the difference in old time, like 20 years and 15 years ago? The quantity takeoff was very difficult field, but now it is very easy because of Civil 3D and AutoCAD and all that other tools. It is available in the market. But if you know how to use that tools in a proper way with the proper accuracy, then it will give you result. Otherwise, they are not accurate. Maybe it become a nightmare for everyone if you are not skillful enough to use that tools.
Yes,
Yeah.
yes, thank you. I think that's very comprehensive. You have actually covered uh, what I wanted to make a comment about. Can we have someone else, please? Okay, so great. If we don't have anyone else who would like to share with us, I would like then to proceed from that point. Maybe this is your first time uh, interacting with the software, uh, or possibly not the software rather, but with this aspect of quantity takeoff. But altogether, that is why you are in this program. So I would like to take you back to the very, very, very part of this, the course outline that we provided earlier on, so that then you can be able to look at where we are at the moment. So from the last session, we were able to do corridor code set styles and all of these corridor modeling. And corridor modeling, just as a summary, is where you bring your horizontal alignment, your vertical alignment, and of course the pavement cross-section together for you to form a 3D corridor that represents your road project. Then after you are able to model them and bring them together, that is when at least now you have a representative of your road project. You have, for example, the formation level of your road, and you possibly have also the finished road level of your project, or rather of your road. So then from that step, you go to the next step, which is basically about cost estimation. And in this one, we are going to talk about fundamentals of value engineering and principles and technique. So basically what the principles of value engineering is where now you control the cost of the project based on your experience, expertise, leveraging technology, and also leveraging people like yourself and cost estimators who are a bit experienced so that you can be able to make sure that the cost of the project is optimal. So value engineering starts from the decisions that we make, the financial decisions that we make, the resource planning, the resource mobilization, and of course, estimation and the actual dispensation of the finances that you have at the project. So value engineering is basically about you as the consultant, you as the contractor, making sure that as you deliver the project, you make sure that it is within the least cost possible and reducing the kind of losses that you could incur in that project. If we talk about value engineering from the perspective of a consultant or a designer where you are, it is about as you make decisions. And for example, in Roadworks, it's about number one, the cut and fill, because that is the major aspect that controls the amount of earthworks that we have in every project. So while you are recommending your cut and fill, and I want to go to this other side. Let me stop sharing my screen. so that I can create a context for the same. Oh, and by the way, please confirm whether you're seeing my screen. I don't want to continue just without you necessarily having access to my screen. Great. So if you look at, for example, these design projects that we have what we call a profile. And we say that the road profile basically gives us the OGL. And once you have the OGL, you will have what we call the formation level of your road. So this formation level of your road, or with the vertical profile, with this formation level, you decide the amount of gradient that you need. These are the major design controls. The gradient of the road. Gradient of the road controls the economy of transport. So we said if the gradient is too steep, then it becomes, the vehicles will require more force to move or torque, and then therefore they will consume more fuel. So that is why when you're driving through mountainous sections, you find that you will notice that you use more fuel. The other thing is, of course, drainage. It's also controlled by the gradient, and it is also controls the speed of the vehicles at that point. So, for example, if you look at this design, we said that to control drainage again, you use a gradient that is greater than 0.5, especially in cut sections. But of course, in field sections, there is an exception. But all the same, the rule of the thumb is you should make sure that you don't have any gradient less than 0.5. So when we look at this design, this is, for example, a cut section. Or this is a field section, rather. A field section is where you find that your OGL, your finished road level, is coming above your OGL. So that is a fill section. So it means you're going to require material to fill this section. Then when you come to cut section, this is where your OGL is, or rather your finished road level is below the existing ground level. So that is a cut section. So it means you're going to remove material or cut it away. When we talk about cut, we talk about it in two perspectives. There is cut to be reused, and there is cut to spoil. So how do you differentiate the two? The main thing that informs whether it is a cut to spoil or a reusable material is the quality of that soil in that area. And in this case, we are talking about the existing subgrade soil. If the subgrade is of the good quality, after the geotechnical investigations of the alignment soil, and for example, we have different classes of subgrade. We have subgrade class S1, S2, S3, S4, S5, all the way to S6. So the main determinant of the classification of the subgrade is what we call the CBR, California Bearing Ratio. So anything that is below 10, a CBR of 10, is always considered unsuitable for use, unless you want to improve it with lime, cement, or any other material. That is chemicals or additives that you may need to use. But what happens, a rule of the thumb is when you improve the subgrade material or any material, the CBR almost doubles. So if the CBR was 10, there's a possibility that you're going to achieve a CBR of, let's say, 20. If it was 14, there's a possibility you can be able to achieve even a 26. But one of the shortcomings that you mostly have with improvement of subgrade materials is that you will notice sometimes the Atterberg limits may not be affected. That is, for example, the plasticity, the soil, and all of these. And of course, they are important components when you are looking at this material. So if they don't meet the requirement for different classifications of traffic, of course, you can look at, for example, RDM Part 3 or ASHTO 1993 for road materials, and you will have a deeper understanding of the classifications that we have for various subgrade materials as related to various traffic classes or loading. So if this material does not meet this minimum requirement, that is when now you cut to spoil. And as an obvious example is when you find there is a lot of cotton soil within your alignment. So that material is cut to spoil. You cut and go and dump it away in another place. But if this material is of good quality, let's say you find that it's gravel, it's possibly some good material, maybe it's some red soil or something that does not have a lot of problem with red soils is swelling. So if you find that the swelling is within the limit, then you can be able to use that material as a subgrade. So as you design your profile, this is the other thing. Well, you already designed what you have here. But then you need to go to look at the alignment report from the materials engineer, and he is going to tell you possibly, let me just draw something. He will tell you at this change, let's say from kilometer, this is kilometer what? This is kilometer 4 plus 100 or 4 plus 90 all the way to kilometer, let's say 4 plus 480. That material at that point is unusable for this project. It is not suitable for uh, for use or for reuse as a subgrade or even as any pavement layer. So it means as the excavation is ongoing, when you get to this change, you cut that material to spoil, to dump it away. But then you will notice, possibly from that report, it will tell you the material at this change, this is kilometer 0 plus 120, all the way to, let's say, kilometer 1 plus 380. It is purely good gravel that can be used. So then it is up to you as the design engineer to see how can I actually get to balance the amount of cut here. So it means I can cut more here. And once I get to cut a little bit of more material at this point, I can be able to use it to fill, for example, this other section that we are having. So it is always an art and skill of balancing. So while you're designing for gradient, while you're designing to minimize the amount of cut and fill, you are also being guided by the geotechnical report. So the geotechnical report isolates sections that have good material that can be reused other section and isolate sections that have poor material. So as you're designing, that is where now you will come and say, for example, this section has a very good material and therefore I want to reuse it. Therefore, what can I do? I will design for more cut instead, because the other again goes back to the principle of value engineering. It is far much more economical for you to cut material within alignment and carry it and reuse it here rather than going far away to look for borrow pit. It will save you the cost of testing materials because you've already done the alignment soil test. You can be able to reuse it. That is again, if the terrain allows. So for example, if you look at this section, it's more of a hilly section. It is a vertical curve, and then we can be able to cut it. It's a crest curve. So we have, you remember the rules of the dump. You don't cut in a sag curve, so you don't cut at such a section. It would be out of question. Why are you cutting where there is already a depression? And you don't fill where there is a crest curve again. So you don't have to fill. So then by the rule of the dump, it would allow you to cut this section. If again, the material is good enough, we can be able to increase the levels, the cut depth at this point so that we can reuse that material to fill here. That is always the principle. Again, goes back to value engineering. You want to minimize the cost of moving materials to and from your site. That is the other value engineering principle. So these are the many factors that affect your design. This is why also when it comes to engineering design, you will never say you have final design until you've done the actual construction. You will have all the detailed design, You will have all of these terminologies that you want to look at, but it is until you've gone to site, you've moved. You know, for example, sometimes you go and do topsoil stripping, and then after topsoil stripping, you're surprised at the kind of materials that you're finding. Because again, you remember when you're doing the alignment soil sampling, you are sampling in a zigzag manner. So one point here, the other on the opposite, one at the center line, the other on this edge, this edge. So sometimes the geology of an area is not uniform. It varies. The soil formation varies from section, from place to place. So then what do you notice? You find that there are a lot of surprises. I was telling some engineers of a story where we are supervising a road project in Marsabit. And during the construction, we had done the alignment soil, the testing, and all of these pavement evaluation, or rather alignment soil evaluation, and all of these things, and ground investigation. During the actual construction, when we came to Hussein, you may mute if that is good enough. Hussein, please. Okay, thank you. So we found that even some sections that we had already designed for minimal cut, after opening up the area, we found that there is what we call lateritic soils. It's like a kind of soil that is more of plastic. It's a bit of rocky, a mix of rock and soil. And again, it's like plastic. When you move with the excavator, it's crushing the rocks to ash at that point. So it was a big surprise that really affected the project earthworks. We had to do an appraisal and even another appraisal, because now at such a section you need to do a lot of rock fill to stabilize the ground. So even as we do the vertical alignment design, it is important for you to keep that in mind, that it is changes when you go to site. There is a possibility. So you don't lock your mind. This is again why we provide markup in cost estimation, especially when you are preparing the engineer's estimate, when you are bidding, and even when you are budgeting. That is, if you're working from the government side, you need to provide markups sometimes of up to even 20%. The rule of the thumb in the industry is around using like 15%, 10%. The others who will tell you markup should not go beyond 5%. But then again, it's a contingency, just like we had in the video. But you need to have that contingency to make sure that, and know, yes, I have these kind of estimates, but there is these changes that could happen, you know. Again, it is what also Engineer Rashid emphasized. When it comes to design and cost estimation, the accuracy, or rather the integrity of the survey data, is more important than actually these designs that we have here. Because garbage in, garbage out. If you have a terrible surveyor, you will have a terrible output. If you are terrible at handling data, you will have terrible outputs. There is no any other rule of the thumb. That is a principle and a fact. So while you are the design engineer, and as you will be going out here, one of the critical things is making sure that your surveying equipment are calibrated, making sure that your benchmarks are well secured. You cast them using concrete and iron pin, and you make sure that you have a good base that will not be moved. As even the excavation is going, we always say that it is good for you to position your benchmark or your beacons away or outside the road corridor, somewhere that you know, even as there is vibration of the machines during compaction and all of these site movement, they are not going to affect it. Because even that 2 millimeters, 2 centimeters, 10 centimeters, that is going to affect the final output, and most importantly, for the quantities of your project. And now, for you as the consultant engineer, or as the representative of the client, or even as the contractor, you will always earn the engineer. Then the engineer is going to earn the surveyor, but the damage has been done. So that is why data integrity is very, very important. So I will pause at that point so that then I can possibly do some questions. I think we've taken enough time to build context on what you need, the importance, so that then we can go to the actual demonstration. In case of any question, you may unmute, and as you can also use the chat box all together. Thank you, very important. Very well. It means then the context and the background is very good. We have already done with we are done with the value engineering principles, and I hope that you've understood it. Number two, also, we've been able to understand the cost estimation for roadworks, the entire process that happens. You will notice that in roadworks, we mostly don't have quantity surveyors. We sometimes have what we call cost engineers. And then, of course, we ourselves as civil engineers also, we do the cost control and cost management and resource management for our works, okay? We have also talked about the major important thing in roadworks, that is cut and fill quantities. And then after cut and fill, we have the pavement layers. So the various pavement layers that you developed in your design using the road assembly. I expected you people to have drafted something. So for example, these are the road pavement layers. So you need also to generate quantities for these pavement layers. We talked about the methods that we use. So there is the unit method, which I think is a bit more accurate. Well, it will take a bit of time for you to figure out all the unit items that you need for your project, both in roadworks and also drainage works and furniture, road furniture, and all of these items. But then again, also in building works, it becomes a bit more accurate. There are a lot of templates online that at least gives you an idea of the number of quantities and items that you need to keep in mind and consider. And then from that also, when you're doing for building works, again, you mostly use the same. There are various units of measurement. So some items will be, we will use numbers. Other items will be using meters, that is length. Other items will be using volume. Other items will be using weight. Other items will be using surface area and various instruments or units of measurement. So they basically depend with different items. I should have looked at some bills of BOQ. What culminates from this process is the ability to prepare a bill of quantities for these roadworks. I'm actually preparing a complete course on preparation of BOQs for roadworks. Others call it engineer's estimates. Others, we have different names in different countries, but bill of quantities, I think, is basically a very good one. So that is basically it. We have different bill items. I'm going to show you an actual roadworks bill of quantities at the end of this presentation, so that then we can be able to connect how this output is going to connect with the final preparation all together. Then after that, we are talking about now the actual computation using Civil 3D. We basically use surfaces. Surfaces help us in creating and design in getting quantities. The first quantity takeoff that you did was for topsoil stripping. That, for example, let me see whether this engineer did it. I think they did not do it. Where, for example, you want to do the topsoil stripping of the entire of this corridor. So there are always two ways of calculating that. you may decide to go and use this method where there is the road corridor width of or right away of, let's say, 40 meters. And then topsoil stripping is, for example, 0.2 meters. That is 200 mm. So you're going to say 40 meters times 0.2 times the length of your section, so that then you can be able to get the volume and the output will be in cubic meters. So at that point, you will have gotten the quantities of the volume for your topsoil stripping. Now, there is another item that is called site clearance. So site clearance is always paid in square meters. And this is mostly, there is a unit rate that is given a standard rate. And I'm going to also show you some manuals that we use for cost estimation here in Kenya. But again, it is the area. So how do you calculate the area again in site clearance? Site clearance will be length times width of the section. So let's say the width is again the road corridor. Sometimes you don't do site clearance for the entire corridor because, let's say, for example, it was an existing road. So if it is an existing road, you know that there is a width of, let's say, 7 meters. That is 3.5, 3.5. If it end a shoulder, which is rarely the case, then you could have included some other 3 meters or the width, that is 1.5, 1.5, or 1 meter or 1 meter on each side. And at that point, then you will be able to have a section of either 9 to 10 meters for that matter. So if the road corridor or the right of way is 40 meters, you will say 40 meters minus 10. That will be 30 meters. And then once you have that 30 meters, you are going to multiply it with the length of the entire section. So let's say, for example, this one is 10 kilometers. So it will be 10 times 1,000. Then you're going to divide this with 10,000. So site clearance is again paid in hectares. So you convert the square meters into hectares for that matter. There is, of course, the item for demolition of existing structures. So, for example, if there are existing culverts, if there are existing box culverts, there are existing bridges, and all of those aspects, again, you can be able to calculate that. Again, that is length times width times depth. So if it is a pipe culvert, you will be able to know what is the volume of the wings. You make the measurements on site, or you use the standard drawings. So using standard drawings is where we know if it is a 900 millimeter diameter culvert, we can be able to know that it needs to have wing walls of this length and all of these figures. But it is always wise for you to do such measurements on site to be accurate. Now, the other thing is site clearance, or rather topsoil stripping. To do topsoil stripping, we use surfaces. And this actually applies even when you're doing, let me give an example. So there is an engineer who want to do some excavation or some mass excavation of a site. They want to build a house in that area. So this house is, for example, let's use this pan as an example. So what the surveyor does, they will go and pick the levels, conduct a survey. When you're picking levels for these earthworks, you need to use a lot of spotlights. That's why you saw a lot of spotlights along this project route. So it gives you accuracy, higher levels of accuracy. The more data you have, the higher levels of accuracy, and also your surface will be a bit more tight. Again, you make sure that the machine is your reference to make sure that you're getting the actual exact location. So you pick points along this entire section. So we will have entire points. And then once we pick that, we are going to come with them import in Civil 3D. And once we import them in Civil 3D again, we are going to, let me say, for example, we are going to use the same method that we used to create a surface. So let's assume this is a surface. This surface will be representing the existing ground. Now, when the excavation starts, one, there is a plan, there is a design that you possibly have. So for example, you are saying that I want to excavate, let's say, it's a dam. It's possibly a swimming pool. So if it is a swimming pool, it's a quarry for that matter. It's a borrow pit. So you will say, I want to excavate to a depth of, let's say, 5 meters. This is just anyway, 5 meters is too much. Let's say 3 meters. And that will give us the foundation level. So what you will always do, you can be able to lower this surface 5 meters down, and you'll be able to get the new levels at that point. So those ones will be design levels. But what you will notice is that you cannot be able to do this point of excavation 5 meters at once. So you will do, for example, the job for one day, because you need also to pay people who are excavating based on the volume of material that is pulled out of this area. So after day one, before we open the section the next day, the surveyor is going to come on site and pick levels for the entire site again. Once we have that site, we will come and prepare those data, same way you prepared for Civil 3D, and then you're going to, or rather for road design, and then you're going to import them and overlay them on top of this design. So we will have a surface, we'll create a surface for that day. So what we do is, this is how you create that. Let's say we have imported those points and you will create a new surface. And that means you're going to have two surfaces. So every day you're going to check, and then once you check, you bring it here, and then you create a surface. You will call it day 1, day 2, day 3, day 4, day 5. Now, you as the design engineer, as the CAD technician, as the surveyor, or whatever, as the cost engineer, you are monitoring the earthworks and quantities. Now, the software here sometimes may have some differences due to the triangulation. So the other thing that you do is also recording the number of trucks that are going out of that site. How many trucks, how many cubic meters are leaving. So that is why you will always find, if it is a quarry, there is someone, the surveyor is doing these things, and at the same time, there is a clerk that is recording the number of trucks that are leaving that specific quarry, that specific borrow pit, that specific site. So that then at the end of the day, what you do, cost control. Cost control is where again you sit down and say, this is what the surveyor has been able to get, and these are the trucks that are leaving the site. So what is the capacity of this truck? We are using a dumper truck, and this dumper truck is 15 cubic meters. So if it's 15 cubic meters, we have recorded 100. So that means we need to have 1,000 cubic meters that were sold, that were dumped, that were given to a specific road construction sector. So you do the control for the two. So let me show you then how you work with surfaces for cost estimation. This is super easy. So let's say, for example, this is our road project, and we want to know the earthworks for this entire section. You can see it is entirely within our road corridor. And again, we don't have anything that is outside this very section. These are just minimal areas, and of course, you can always sorry, Ramadan, would you mind muting, please? Ramadani, guys, sometimes it's interesting, huh? Good for us to have some etiquette and respect at least the session, even if you don't respect the person presenting. Respect your fellow colleagues. Thank you. No, so we were talking about, so you'll have the existing ground. Let me give you an example. You select this surface, and once you select it under tool space, you can always select it and right click. The beauty of it is you can always make a copy of this. So look at it here. So you will go to the tool space. This is OGL. You can go to definition. And once you go to definition, you can go to edit, right click. Let me show you. Let me show you something. Okay, I can see that. Now, let's do it. We want to create a topsoil stripping for this entire road project. So how do we do that? The first step is we need to create a new surface. So we'll go to surfaces, create new surface. And in this case, we are going to name it and we are going to call it top soil stripping. I don't know whether this was covered. Was this covered, please? So once you do that, you're going to make a copy or rather rename it and then press OK. Once you do that, you will notice that in the tool space, you will find tool topsoil stripping right here. And once we do that, we want now to go to definition. So expand the option for definition. And once we go to definition, we go to edits. So we want to edit this surface. In editing this surface, you right click. And once you right click, you can see there is where we say paste surface. So pasting is basically copying the OGL. We want to make a copy of the OGL. So we will make a copy of the OGL and then press OK. Great. So we have already a topsoil stripping, which is an overlap or a copy of the OGL. Now, once we do that, we go into definition again, edit, right click, and then we'll have to raise or lower. Raise or lower. So if it is a fill section, so you want to fill to 10 meters to 3 meters, you want it at least to be at that level of the OGL, you can be able to do it all together. All right. So this one is a cut. So we are going to do a negative. So we say negative 0.2 meters and then press enter. So what you will notice is the software will say we have lowered, raise or lower this surface at a depth of 0.2 meters. This is the stripping that we'll do at that point. Now, we need then to create another surface. Ramadhani, you are drawing on my screen again. Please, let's not distract others. Ramadhani, you are not attentive. And at least now, let's not disrupt those who are attentive, my brother, please.
It's just accidental.
You know, you cannot be attending these sessions when you are in a noisy place. So we'll create another surface. We'll create a surface. This time, we are going to create what we call a thin volume surface. Thin volume surface allows us to compute volumes and quantities for this one. So this one, I'm going to call it QTO stripping, okay? And it compares between two surfaces. So our base surface at this time will be our OGL because that is what we are comparing. And then our comparison surface at this point will be the topsoil stripping. Those are the two major things that you need. The cut and fill factor, we are not compressing, we are not compacting material. So we are going to use a cut factor of 1, then press OK. Once you do that, you will notice that the QTO has also been created here under surfaces. Remember, you can have as many surfaces as possible. So if it was in the context of a borrow pit, each data that you're going to import, you're going to use that data. Remember, we're going to use point groups. So you will come here and create a new point group. And then, for example, you're going to call it day 1 point group. And then apply and then press OK. So once you have that, when you will be importing your day 1, that is after excavation, you will come and add them in this point group. So what this does is you are able to separate the survey data from day 1, day 2, day 3, day 4, and basically the elevations, so that then you can be able to use them for various surfaces. So when you create surfaces, so for example, let's say, let me create a new surface here, and then in this surface, I'm going to call it day 1 excavations, okay? And once I create these day 1 excavations, look at this one. Under day 1 excavations, I'll go to definition. Under point groups, I'll right click, add, and then I will add the survey data that I have on day 1, my guys, if you understand. So I'll add the point that I have in point group 1, and then apply, and then press OK. So at that point, that surface will be only constrained to data for that specific day, ladies and gentlemen. So once we do that and we create all of them, you will come again and create you will create the QTO for each day. So you'll be having QTO day 1, QTO day 2, QTO day 3, and all of that information. Once you do that, you can be able to say sorry. So you can right click on this and say select. And once you select, remember, sometimes it's difficult for you to know which surface is here, to select them in the drawing. So I normally use the tool space, select the QTO, right click, and I will say select. So once I select that, I will be able to get a contextual ribbon. And in this contextual ribbon, I will use this function. Okay, let me deselect them. I think I've selected the wrong one. Okay, let me not, okay, select, and then I will go to what we call under analyze. I will find something that is called volumes dashboard. Volumes dashboard, please remember that. I'll select volumes dashboard. And once I select volumes dashboard, there is a dashboard that is going to pop on my screen. What I'll do, there are 2 icons here. Now, the first one is to toggle, so we don't need that. The second icon is add volume surface. So we will select that, and you see the QTO stripping is in. So if it was the context for mines, for excavation works and all of those, and you want to track them on a daily, so you will be able to find day 1, day 2, day 3, day 4, day 5, all of them here. And then you can add one at a time. So once we do that, you can see it's already right here with us, ladies and gentlemen. And what you'll notice is the cut factor was 1. The style is not as necessary. We can be able to see the total approximated 2D area for our section. We can be able to have the adjusted cut volume, and you can see the net cut volume. So the reason as why it has adjusted cut and whatever, this is a cut section because we were just going down. But of course, if it was a fill section, then this would automatically talk about it can automatically talk about the fill materials, ladies and gentlemen. So once this is done, you can come to the next icon. Remember, you can add as many. Oh, sorry. You can add. You can be able to select. I think my computer has done that thing. Huh? I don't know. Okay, let it load. I think some operation is here. Sorry. So what I need to do is, for example, generate a simple report. So I'm going to generate a simple report here. So I click this icon for reports. The problem is it's showing in my other, I have an extended view of this computer, but I hope you can be able to see it now. So you can be able to see the total volume. So the beauty of this is it is actually used mostly for cumulative volumes, and therefore it will not be able to separate them into specific changes that we'll be having at each section. So please check that out and make sure that you'll be able to do it. Now, that's done. Let's go to, if there's any question, please drop it in the chat box, and I'm going to be able to respond to all of them all together to make sure that you understand. Thank you very much. Now, let's talk about something else here. And this is always a confusion. And I don't want you to be confused. I want you to get this clear because it is important. And again, it tests your level of understanding. Now, how does that work, ladies and gentlemen? This is how it works. When you're designing your road, I remember you are following this OGL as it is. You know, you are following the main guide is OGL. Reason being, you cannot design from unknown to unknown. So you always design from known to unknown. So we already know the OGL. So if we already know the OGL, then it can be able to guide us all the way to get the finished road level design. That is simple. Again, as we design, we see that we are being guided by the alignment soil report. So we know sections that we need to cut. We know sections that has a lot of bad material. We know sections that has good material. And then that insight and wisdom will be behind you. And then you will be able to know how you design different sections to make sure that you utilize the materials effectively. Are we together up to that point? I hope we are. Now, this red line that you are designing is not the finished road level. This is the formation level. It is very difficult for you to start designing the finished road level. What we design is what we call the formation level. So you design the formation level first, and the formation level is when you've done your final earthworks, or when you've prepared your subgrade and it is ready. It is your final subgrade, and you're ready to do now the pavement layers. So you're ready to drop in the sub base, you're ready to do the base, you're ready to do all of this. Now, there are two specific scenarios. In the first scenario is an instance where you're going to import or you're going to fill, bring new subgrade or sorry, sub-base and base material. So for example, that you need a quarry so that you can bring neat gravel that meets the minimum CBU requirements for you to construct your sub-base layer. So what does that mean? Remember again, this is informed by the alignment materials report. So it means this material that we have here can only be suitable for the subgrade. That is when, now, what is the design approach in such a scenario? In such a scenario, what you do is like you're just leveling the ground. You know, that is what you are doing. You are just leveling the ground. You will say now the layer is already good enough at this point. The layer is already good enough. Remember, the layer is already good enough. The layer is already good enough. So you're just leveling it. Where sections that you need to do cut, you cut. Sections that you need to do fill, you do the fill. Whatever you're doing here, you do it all the entire section. That is what you are doing here. That is the first scenario. Now, then you think about the actual construction. What is going to happen? So in such a scenario, what is going to happen? You're going to excavate the depth of your subgrade. So what is the recommended depth of your subgrade at that point? So let's say the recommended subgrade at that point is 300 mm. So subgrade 1 is 300 mm. Or okay, so this means we have two layers of subgrade. So we have subgrade 1 and subgrade 2. Each one of them is 150 mm. We limit our pavement layers to layers of 150 for ease of compaction, for us to achieve compaction, and for ease also of testing and sampling using the sand replacement method. Unless you are using the the nuclear method to do the testing to know the amount of compaction, whether you have achieved compaction, then again, it has a lot of effects to dispose people to radioactive radiations, rather. Okay, at that point. So then what would be your approach? So it means because the materials engineer has told me the material on this site is good enough. So what I'm going to do, I'm just going to, after I do the design of my proposed formation level that ensures that I'm meeting all the minimum design criteria, what I'm going to do is basically, I don't know why. I don't know why my computer is misbehaving, but it's weird. Eh? Oh, it's because of this shared screen. Let me see. Let me see. This is quite unusual. It's quite unusual. Or the mouse batteries are out. I don't know. But that's quite alarming for me. But anyway, uh, I want to demonstrate something here, my good people. I want to demonstrate something. My computer is misbehaving in a very bad way. Hey, something is wrong. Okay, just one more time. All right, all right. Oh, this is interesting. Okay. This is very, very interesting. Anyway, what you do, I wanted to draw a line here so that I can use it as a sample to demonstrate the kind of magic I want to do. So it means that I don't know what is happening. Something is weird. I don't know what is it. But basically, what this would mean, it means that we need now, with this formation level that we've designed, that has met all the minimum requirements that we have in the road design manuals, we can then be able to say that we will dig, mm, we will have a lot of cut, we will have cut material so that we are able to achieve, we can be able to achieve the depth of the 300. So it means most of the works at this point will be excavations. So what we'll do, let me show you what I wanted to do, my good people. So what we are going to do for us to get now the final formation level, we said formation level is the final subgrade works. So it means this section will be a lot of, a lot, a lot, a lot, a lot, a lot, a lot of cut. Because we have been told we can be able to reuse the materials that is existing on that very site. So we don't need a new borrow pit. Yes, of course, when there is compaction, the material is going to reduce significantly, but then that tells us we can be able to, at least the material that we bring on site is not as much, okay? Great. So what this means for us is we need to lower these finished road or rather formation level to somewhere like here. I'm assuming this is where the 300 is. So you select the FRL or the formation level. You make sure you've turned on the other mode. And then once you select it, you hit what we call move. Now, the question will be, how will you determine where the 300 mm is? Now, you select the profile. Once you select the profile, you will find in the contextual ribbon, there is the option to profile view properties. You will select the drop down and go to profile view style. And a profile view style, you will notice that there is some information, and then there is the graph. There is always a different scale, just like when you were in primary school. You enter the option of using a different scale for your x-axis and your horizontal axis, for your vertical axis and your horizontal axis. Same thing is following you here. Look at it in this way. There is the vertical scale. The vertical scale here is 1:100. The current horizontal scale for this German is 1:200. So you see, there is a ratio which is called the vertical exaggeration. Now, to make this clear, when we talk about horizontal scale, it is the drawing scale that you set at the bottom here when you are starting your project. I said mostly for project, it's always good to use a scale of 1:1000 for a project that is less than 50 kilometers, thereabout. If you have something above that, you can use a project of 1:2000 going forward. Again, it also depends with your ability to see and how easy it is for you to work. So that is just but a rule of the thumb that you are free to modify. If you look at this, there's something they are calling vertical exaggeration, which is a ratio of your horizontal to vertical scale. So even when you go to plan and production, you will always notice that the scale for the plan is always different from the scale for the profile. So we have known this is a two. Now, how do we integrate these into our design levels? This is super easy. So we'll say if our subgrade is 300, it means that is 0.3 meters. And then we are going to multiply it by the vertical exaggeration. So you will come again to profile view and you will multiply this times 2 so that you can get a 0.6. So what this means is instead of 0.3 or lowering our vertical profile by 0.3, we lower it by 0.6. Different people here have different values for vertical exaggeration. Different people have different values for vertical exaggeration. So don't use my 2, don't use someone else's 3. You will have it in your own design. Now, remember, that figure is not cast on stone. You can always get to modify it. So for example, I can come to edit profile views. If I change, for example, the vertical scale to, let's say 1:200, you will notice that the vertical exaggeration here has become 1. If I change the vertical scale, let's say to 1:50, the vertical exaggeration has become 4. And you see now, even the graph has changed significantly, all right? So those are some of the things that you need to work at. So what you will do is you will come to this again, select the FRL, hit move command. And once you hit move command, you will select the starting point here, and then you will lower it where you want to do. So what I normally do to make sure that whatever I'm doing is right, I normally put a polyline here, and then I offset the polyline by 0.6, and then I will lower it on the bottom side, and then I can be able to make sure that while I'm moving my FRL, it does not go beyond this. So this is just like a check, and once I'm done, I can be able to delete my, I can be able to delete, I can be able to delete my polylines altogether because they were just guiding me. Question up to this point, do we understand the relationship between this point, how the FRL, the formation level, and how we make sure that we balance the two? Any question, please? You may drop it in the chat box, or if you can be able to unmute, you can also share with me here. Good. Silence tells me I have fantastic students, or I don't know, I am unable to articulate my points, but I hope the latter, or I hope that the fact that I have smart students who can be able to grasp these things. I'm taking my time to make sure that also you understand. I don't have a hurry to go anywhere. Now, fantastic, super fantastic. Now, the next thing we need to do, we want to think about the second scenario. So the second scenario is where we, from our geotechnical report, we have known that all of this material is cut to spoil. So we need to excavate 300 mm and cut it and throw it away. And then once we throw it away, then we need to bring new materials to that specific site. It can be quite something. This is how you approach it. The first thing is you will go down to 0.6 meters. And then once you go to your 0.6 meters, you will generate your report at that point. So you will save that report, the quantity cut and fill report separately. Quantity takeoff is a multi-step and it is a scenario based. It will be changing with the scenarios that you have on site. So don't have a fixed mind on how you approach this scenario. Sorry. So you need to think about that. So we'll do it as it is on site. So the contractor, the materials engineer will tell you, so we need to excavate 0.6 meters so that we remove the entire of this material. It's purely bad. For example, in arid and semi-arid areas where you have a lot of sand. So we excavate it and dump it away. You will lower it to 0.6. And then once you do that, you will generate a report and save that file or report as it is. Once you do that, now with the new levels, you will then again come up again and you go up. You fill. So there is always an assumption that the amount of material you're going to cut is always the same that you're going to fill, which is not true. Because in this case, you are going to do compaction. So we achieve a 95% compaction. So then this means that when you're getting the amount of fill material that you want to bring there, you can be able to play around 110%, 105%, all the way to 110% because of that shrinkage and the compaction that is going to happen there. So that then you compensate for that compaction. So a 5% compaction is good. Others will go to 10 just to be safe. Others will go to 15 just to be exorbitant. So it is up to you, and of course, based on your experience and the different materials that you have on site as you do that very compaction. Now, that is the other scenario that is always there. Then from there, you will be able to know. The moment you know the final subgrade, that is when you generate your quantity takeoff. Once you're done generating your quantity takeoff there, you will then offset this to the final finished level. The final finished level is where you get the layers for subbase. So let's say our subbase is 150, our base is 150, our surfacing is 50. So that becomes around 350. So that is 0.35. You multiply again by our vertical exaggeration factor. Let's say times some will even have 10, and therefore this will become 3.5 meters. So what you do, you are going to offset this FRL again by 3.5 meters, but at this time you are going up. So at that point, you will get what we call the final design levels. So those are the final design levels, and those are not formation levels. Those are the final design levels. That at that point, then you don't need to do cut and fill. Because if you do cut and fill at that point, you will be saying that you are filling a layer of 3.5 or rather 350 meters for those pavement layers, which is not true. The software can be able to calculate quantities for the pavement layers separately. So it is going to calculate the subbase, the base, the AC separately, and then you will do the cut and fill, which is the subgrade, or rather what we call the foundation of the road. I don't want to spend a lot of time on those theories. I hope I'm super clear and we are able to understand. Uh, mm, I hope you're able to understand and it is easier for you to do it. Now, someone talked about an important aspect, the culvert. And now, when you're positioning a culvert and a bridge, you already have the design and the specifications. So let's say, for example, you have a culvert of a 900 millimeters culvert. So that means you need to have a picture in mind of how the typical cross section of a culvert looks like. So you'll need to have a bed of 50 mm below it. Then at that point, you have the ring of the culvert. That is the thickness of the ring. So sometimes it's 200 mm. And then after that, you will have the diameter. Remember, the diameter you measure internally. It depends on the production specifications. So if you're measuring your culvert internally, then this means this will be 900. And then there is another 200 here. And then there will be another 200 on top, okay? Or 150, it depends again with the specifications. Some have 150, the ring is 150. Others, I think mostly it's 150, not 200. You have the bed of 50, you have a ring of 150, you have the culvert of 900, and then you have another 150 here. And then on top of that, the minimum cover, there is something we call minimum cover should be a 0.6 meters for any culvert, whether submerged or emerged or whatever it is. Now, how do you determine the location? It is obvious. You need a culvert at this point to drain water. You're having water coming down from the left-hand side, and you're having water coming down from the right-hand side. So you need to position a culvert somewhere here. Same thing again, it's common sense. You will need another culvert here. All of this water will be draining to this point and these others. So we mostly position culvert at sag curve. Well, if the crest is too long, for example, this one looks like a bit longer. This is from kilometer 3 plus 500 all the way to kilometer 5. That's like 2 kilometers. A rule of the thumb is if it's providing culverts at intervals of 1 to 2 kilometers, 1.5 to 2 kilometers. Again, your terrain is what informs you. Um, the climate of the area, if it's a rainforest area, it means you will have a lot of discharge. Your hydrological analysis again is also going to give you information on the amount of discharge that we expect in that area. So, for example, this would mean the area here receives a lot of rainfall, so you can be able to have a reliever culvert. So you can position a reliever culvert here. The culverts that are positioned on crest curves are mostly called reliever culverts. You also need them if you, for example, you are in an embankment and the left-hand side doesn't have outfall, so you can be able to provide a culvert that is just meant to shift water from this side to the other side of the road. Again, the drainage of the area mostly is the terrain that informs you. So you make your judgment and say, I want to remove this water or channel this water from the left-hand side to the right-hand side. Okay. So that is the principle. Now, how do you integrate that in design? This is how you do it. Let me do that for you. Let me do that for you. I'm looking for something here. So there you go. Now, super fantastic. How you do it when now you are positioning these sag curves here, because that is where the culvert, you must know the chainage, the exact chainage. Again, you do these inspections on site to confirm that this is going to work for you. So this is what you do. This is what you do. Basically, this is the manual method of doing it. So you know this is the OGL. This is the OGL. So you normally create a culvert that is, or rather, for example, a circle that has a diameter of what you have calculated here. So this will be 150, 150, that is 300 mm. 300 plus 900, that becomes 1200, plus 50, that becomes 1250. So that is 1.25. Actually, as a rule of the thumb, we normally say from the OGL to where I want my final levels of the road, I want to have a depth of at least 1.3 meters. This is a rule that we mostly use in our design here in Kenya. So you're going to say, I want at least to have 1.3. Now, with this 1.3, remember again, in this case, we are talking about a vertical profile. So when we are talking about vertical profiles, you must again multiply it with the vertical exaggerations that we need for you now to get the exact accurate figures. Now, look at it again. I want you to, I would not recommend this kind of scale. You know, this guy is moving from 1960 all the way to 1980. So this one bracket has a difference of 20 meters. I think this is 10 meters. That can be very inaccurate. It's good for you to have the axis here spaced at 2 meters interval so that it is easier for you again to create that mental picture. Either way, I'm not going to spend a lot of time on this matter. So let's say we are going to use a diameter here of my culvert of uh, of uh, of 1.2 meters. And then what I will do is I will come to the design of my profile. So I don't know, my computer is having problems. Someone was telling me I have problems and I can see the problems. So what you do in your design, you make sure that at this point, the design profile of your road is at least at this point. You see? So this is how drainage affects your design. So you can see at this point, I'm going to have a lot of fill so that my road level fits here. You know, fits at this point. Then I think in the next session, I'm going to show you how then you do go and use pipe networks at that very exact alignment here, at that very exact point in your alignment. And I'm going to have my pipe network here. And once I create it, I can be able to impose it on my profile and show the exact crossing point of that culvert. Where is that culvert? Now I forgot the chainage we were working with. It's here. So that then I can be able to know the exact crossing point that we have at this point. So that I can know the levels at this point and the level, mostly is the level of the top of the barrel. This is the top of the barrel. So the moment you have the top of the barrel, you can then be able to know that my road layer now needs this amount of depth up there. So that is the approach that we use in the design of placing culverts. Again, it's the same thing approach in bridges. So bridges, you will always notice that a section that requires a bridge is obviously visible without any need for explanation. So it is, for example, from this cliff to this other cliff. So what you need is to just know that your bridge will, for example, the bridge spire will be at this point and all the way at this other point, and then you control the levels all together using the very same approach. You need to know the clearance, you need to know the depth of your sections, and then all the way you will be able now to balance your levels together using the same approach that we have here. Now, I've not actually even been managed to cover most of the things that I wanted us to cover. But basically, if you are going to sample any project, if you are going to get quantities for any section, just like Rashid said, you divide that section into small so that you can sample it. So in Civo 3D, we use what we call sample lines. They are under home ribbon, profile, and sections. So we have sample line. Once you click sample lines are associated with alignments and not corridors. So it will ask you to select the alignment, and you can see we have many alignments here. So I don't know which is the main one, but I can use that icon to come here and select the main alignment. I don't know what is the main name of the main alignment, but either way, I'm going to use the main horizontal alignment. So once I select the main horizontal alignment, there is a dialog box to create this sample line group, and I'm going to rename it, say SLG. I think this gentleman's name is Yoni, so I'm going to use SLG Yoni. That is the name. The style, you can use the road sample line style. It's obvious. You don't have a lot of problems there. And what you are sampling. So remember, when you are getting volumes, we are sampling everything that is in our design. So we are sampling the existing route, we are sampling the topsoil stripping, we are sampling, you see, for example, this other surface, every surface that is here will be sampled. But if you don't want it sampled, you can uncheck. You can see the road corridor is here, the top road corridor, the top finished drivers, and then also the datum is here all together. Once you do that, you press OK, and then the software is going to bring the sample line tools. The sample line tools, you will notice the sample line group is here, and it is basically the same that we created. So this is a layout tool. There is nothing much you can do with it other than actually creating the stations. You use this icon that looks like a hammer, and you will create stations or you will create sample lines by range of stations. And once you select by range of stations, you will have a dialog box. In this dialog box, there is something that is called swath width. Swath width is basically the width of the road on each side of the alignment. So we know that our road corridor is 40 meters wide. So it means we can be able to use 20 on the left and 20 on the right. The beauty of these is it covers the entire alignment. But if you want to changes to other sections, you can actually change. You see here, from alignment start, you can change this to false, and then you put a station. So it means you can be able to sample a small section, not necessarily having to sample the entire road section. So once you do that, you press OK. And the software is basically going to create sample lines for you, my guys. Like, it's the easiest thing you will ever do in this life. Like, from this point, it's just how Rashid was saying, you can, once you have accurate data, you can work with these things while you're sleeping. So it has created sample lines within the entire road. These are the sample lines. These are the labels. It has used the stations. So this is kilometer 1 plus 580, you know, kilometer 1 plus 6. And it has created for the entire section. Remember, even if you have different alignments, you can still be able to create for different alignments. So you can select, for example, alignment 2, press OK, you will repeat the same thing, you'll name it differently and do it. So if you're designing a section that has many small roads and in an urban area, you can still use the same magic. Once that is done, the next thing is to just do quantity takeoff. So you'll select one sample line, and once you select one sample line, there will be a contextual ribbon that is telling you compute materials. So you can be able to select that. It is going to ask you the alignment. So you select the alignment and the associated sample line group. Press OK. And there is now this dialog box that we have. This is a dialog box that we use for computing materials. It is very easy, and we use different methods. So you can see there is what we call the cut and fill. There are different methods for earthworks, and all of these, you'll notice them. But for those ones, I'm going just to prepare the short videos so that it is easy for you to notice or to understand. So when it comes to computing the cut and fill, we have ground removed and we have ground fill. So ground removed is cut, ground fill is fill. So it is always a comparison between two surfaces, ladies and gentlemen, and we use the average area method. So it's just that one change. You see that one sample, that one sample line, between one sample line to the next one. The software calculates the area and then the depth, and then it gets the volume. It's as simple as that. So what we do, we select the bottommost layer. So in this case, it will not be OGL, because now this is always a contradiction, and I think it's just a logical question. So if you are stripping your section, will, if you think of it in the context of the actual execution of works, what will be the base? What will be you? Will you be considering the existing ground again, or you'll be using the topsoil stripping? So it's basically the topsoil stripping. That is what possibly some would do. And then now the datum is what you used as the datum. So remember, if you have done the topsoil stripping after that surface now is automatically going to be your existing ground, because you've already removed a 200 layer on top of it. So once you do that, you just assign the datum surface that you created, and then press OK. And the software actually does the calculation for your quantities. This is so easy, man. Like, this is the easiest thing you will ever do. And then once that is done, you can actually come to generate volume report, and you will select the alignment material, and you can see it has already called it materials list number 1. And then once you do that, you can see the various templates that we have here. But I don't recommend using this method because it is sometimes misguiding. So let me go to the tool space. Once we go to tool space, you can go to toolbox. Remember, before you do anything, you must make sure that your corridor is up to date. So I don't know why. So let me rebuild this. Maybe there were some changes that were done. So it is always good to make sure that your corridor is up to date, so that then it can be able to cover every detail. Again, once you do that, you can confirm whether all materials are being sampled. So you can select one sample line. And once you select it, in the contextual ribbon, you will find an icon for sample more resources. And you can see we are not sampling day 1. We are only sampling the OGL, topsoil stripping, and all of these other materials. Remember, when you are talking about quarry works, you don't need to come to this process. This process is only for road works. So you don't have to come to this process. If you are doing quarry works and all of those things, you can you can be able you can be able to use the other method of just two surfaces and all of that. Fantastic. So we confirm that everything is being sampled. Sample more resources. So let me explain this. You will see available resources, and you will notice on this other side, sample sources. So the things that are on this side of sampled resources, it means if we calculate quantities, they will be included in the report. So for example, OGL, but if I want to remove it, I'll select and then remove. Topsoil and then remove. It means at this point, I will only be calculating volumes of the corridor and then the datum, and I think the top. If they are missing, so for example, if I create a new surface, it will be on the available sources and it will not be sampled, because I've created that surface after I have already created sample lines. Therefore, it will not be sampled. If I wanted sampled, I'll OGL, add, topsoil stripping, add. Okay, if I wanted to add all these other resources, I can be able to add, apply, and then press OK. What the software does, it updates the quantities and recalculates them for you. Once you do the calculation, you will come to Toolbox. Under Toolbox, you will go to Reports Manager. Under Reports Manager, you will go to Corridor. I will have an entire session with you on how to handle reports. There is even actually a free course that is on our website on how to handle various reports. You can always check it out. I will go to Corridor, and then I'll go to View Volume Report. I'll right click and then execute. So what the software does, it helps me to calculate the entire, when it tells you this, execute, when it tells you no sample line group available in selected alignment, it's because you have many alignments, and some of them, for example, we have offset alignment and all of these, but some of them don't have sample lines. So just press OK, and then it will give you a dialog box to select the alignment that you want. So ours was the main horizontal alignment, and you'll notice there is a materials list. So the materials list is what is has already computed. You can see the changes is from kilometer 0 to kilometer 8, but there is the option of save report. So I recommend that, let me just go back. I recommend that you select this icon where there is a folders icon, and you save it as a workbook, Excel, so that it is easy for you to manipulate it. And then on the type of, you can name it whatever you want to name it, and you can save it where you want it in your computer. So for me, I'm going to save it in the reports and then save. So automatically the software will give it in HTML, but it is always recommended that you save it as a workbook. Once that is done, you can command it to create a report. And there you go, my guy. You have a report. So yours under prepared by client, it will not be having a lot of information. You can, of course, get to delete these rows. They are not necessary. So you will have the volume report. So you can modify these and call it cut and fill. You can call it cut and fill. There is the name of the alignment, the sample line group, and the stations, which is good. So you'll have the first column where you have the stations. So the intervals for the stations is 20, 20, 20 meters. There is the cut area. That is why it was using the average end area method. So it is going to calculate the average cut area in that station for that matter. And for example, kilometer 20, it's 10, kilometer, all of that. Then there is cut volume. So this is the cut volume that you need for that specific station. This volume looks weird. So these are some of the errors that you need to be scouting. So you will notice that you cannot have a single station that has a volume of 302,000. So then that tells you it is automatically an error. So you can go back again and look at your station, and get to understand. So you will mostly find, for example, it's because your alignment is outside the surface. That is why, again, we said when the surveyors are doing the engineering survey, if they import it and you find that there is any point, for example, this road, you found that there are sections that are not within the surface, you instruct the surveyors to go back and do adequate surveying. So it means they are going to go back on site and be able to collect extra data on sections that are outside the road corridor. Otherwise, if you don't have a surface in that section, you will get the quantities or the volume quantities wrongly. That is why you're seeing one station here, the software is telling us we need to have this crazy amount of cut. So you can see all of this figure is wrong. So this is a way of flagging out things. It's impossible for you to have one section with a volume of 302,000 cubic meters. So then that is how you go down slowly. So you'll find that there are sections that are zero. So this means it is you see, this section is for cut. So if you see a 0 in this section, it does not mean the software is wrong. It means it's a bit more of a fill section. So you will notice there is a section for fill area, fill volume, and cumulative volume. So you will notice there is a column for cumulative reusable volume. So in the cumulative reusable volume, the software applies value engineering principles. It assumes that the material that you cut here is the material that you're going to reuse in the next station. So that is why we were saying the geotechnical report is important, and it is going to tell you, for example, these specific stations, it is cut to spoil. So you play around with numbers to make sure that, again, you are able to remove and modify it according to the needs of your project. So that is it. From me, this is the report. Take your time to go through it. Due to the interest of time, we stand a bit late, and I do not intend to spend a lot of your time. It was the mistake of me and our team not to have the meeting link working. So I don't want you to incur the cost of spending extra time here. So we will stop at that point. I'll share videos with you so that this process becomes very easy. I want the next session will be discussing about, do you think the volumes that you're getting are realistic for the actual construction of project? So the task is to talk up with the engineers and ask them, what is the amount of field, just ask them good questions who are experienced than yourself, so that then you can have a feel and practical perspective. There's someone, the more experienced you are, you can see a project and this project is going to take, it's going to require this amount of fill material. So that then you don't over design or under design. You don't make the project unnecessarily expensive for that matter. So those are the parameters. And that's why talking with experienced engineers and showing them your work is very important to help you in better decision making. So that's it. That's the question we'll be answering in our next session on Thursday. Please, 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 and I'm asking you in the name of God, may you create some time to work on it. But all the same, I noticed that if we don't have sessions, it's hurting all of us. For us, our schedule will be messed up. We will have clashes in our program. And for you, possibly also will be wasting your time and your intention. Possibly some of us have already achieved what they wanted in this program. We are not able to communicate. So we'll proceed with the sessions. We are again senior professionals, and we know our agreement that we had when we were getting into this program. So for me, what I'm going to do, I'm going to do my part, and I will leave the rest of the part to you. But there is no session that is going to be postponed or delayed because people are not working. So thank you very much. I'm wishing you all a fantastic night. And I'm looking in the chat box just to make sure whether there is any question. Hussein Ali, I think your question has been answered. Thank you, Gabriel. I must have looked at that, but I didn't. Sorry. How can we place culvert? I think I've done that. Ramadan, you feel bad for any inconvenience or disruption. That is understandable. It's good to show remorse. But please also in the next sessions, make sure that you're in a quiet place. And if also you are on transit, just make sure that you're muted and be mindful that others are going to look at these recordings and use them for their own resources. So thank you very much for all of you for your time. There are no hard feelings. Thank you. And I wish you all a fantastic night for those who are sleeping. And for those who are working, we wish you a productive time. Thank you very much, James, again, and have a fantastic time until we meet on Thursday. I'm sharing the videos right away. Thank you very much. Thank you. Thank you. Good night, everyone.